Hello students, welcome to our online video tutorial class. So in the previous video you have seen that there I have discussed about the double fertilization mechanism entirely, as well as I have started the portion that is post fertilization structures and event, and in that portion only I have discussed about the first point, that is endosperm. Second point onwards I am just starting here in this video the different points which are actually present after endosperm. That is first one, that is the embryo structure. Second one, we have to discuss about the seed. Then we have to discuss about the fruit and its types. Fourth, apomixis or parthenogenesis, what is that? And fifth, polyembryony. So first, when we are starting with the embryo structure, first of all we all know that within the structure of the seed the embryo is generally forming, and when I have talked about the endosperm, on that time I have told that initial embryo structure which is forming, that is called as proembryo. After that it is getting modified into the intermediate form, that is the globular embryo, and then the globular embryo is getting again modified to form the mature embryo and heart-shaped embryo. So now the point is that after those specific embryo structure, here we will be discussing about how the dicot embryo and monocot embryo is looking. First of all, within the dicot seed, if you will enter, you will be seeing this kind of embryo structure. Okay, in case of this embryo structure, generally first of all this is the plumule. Plumule means from where actually the shoot is actually growing. These two are actually the cotyledons, because this is a dicot embryo, so automatically these two portions will be making the cotyledons. Next, this specific portion is commonly known as epicotyle. Epicotyle means it is the portion which is present above the cotyledon. That's why the name has been given epicotyle. Next, this is the hypocotyle portion. This hypocotyle portion is the portion which is present almost in a similar level or below the cotyledons. That's why the name has been given hypocotyle. Hypo means below, cotyle means cotyledon. And here epi means above, and cotyle over has came from cotyledon. So next there is a portion that is a radicle, from where the root will be arising in future, and at last the apical portion of the radicle is enclosed by a cap-like structure that is commonly known as root cap. So this is overall the structure of the dicot embryo. Almost you can see the structure is overall comma-shaped structure. Okay, again I am repeating, these two are cotyledons. This is the plumule from where the stem or the shoot is arising. This is the portion which is above cotyledon, that's why the name has been given epicotyle. This is the portion which is almost in the same level of the cotyledon or below cotyledon, that's why the name has been given hypocotyle. This is the radicle from where root arises, and this is the cap-like structure covering the radicle, that is the root cap. Moving for the monocot embryo structure. You can see the monocot embryo structure is quite more complicated than the dicot embryo structure. So first of all, here we have to start with the structure, that is the scutellum. What is actually the scutellum? Scutellum is actually a shield-like structure which can be found in case of monocot seed-like structure also. So scutellum is actually the shield-like structure, always keep remembering. Next, these two portions are known as coleoptile. Coleoptile is actually the covering of the plumule. Plumule is covered in case of monocot embryo or monocot seed by the help of coleoptile. Next, this is the point which has been given, that is shoot apex. That means it is the apical portion of the shoot. If it from here the shoot is arising, that means the apical portion is covered by the help of coleoptile. Next, this is the epiblast. Epiblast is actually a cell layer, or it is the epithelial cell layer which is exclusively responsible for producing extra embryonic membrane portions or extra embryonic membrane layers. After that, you can see here the radical portion is present, from where in future root will be arising. After radical, automatically you can see the root cap, because root cap is already there in case of dicot embryo also, covering the radical apical portion. And after root cap you can see there is a presence of polyorhiza. Polyorhiza is also again the covering of radical, okay, or rather the root portion from radical portion from where the root will be arising. So always keep it in your mind when you are drawing the dicot embryo structure. On that time plumule and radical you will be showing, but coleoptile and polyorhiza, that means the coverings of plumule and radical don't show, because those are not present. But in case of monocot embryo structure, those coleoptile and polyorhiza, both structures will be present. Okay, keep it in your mind that. And with that extra one more point, epiblast is present, which is forming the extra embryonic membranes later. And with that also one more portion, that is scutellum, that is the shield-like portion or a projected portion, that is also present. Now we are coming for the next point, that is Seed structure. Seed, we all know that seed is a portion which is actually present within the fruit, and ovules are actually getting converted into the seed after fertilization. So first of all, we have to know about the structure of the seed. The basic or the general or ideal structure of the seed, first of all, they are present the seed coat. Seed coat means the covering of the seed. There are two layers are present. First layer or outer layer, that is the testa, and inner layer is commonly known as tegmen. So testa and tegmen are those two layers surrounding the seed, outer coat and inner coat. Next, cotyledon. Cotyledon, already we have seen, cotyledon means actually a portion of the seed from where actually the food remains stored. In case of monocot seed, single cotyledon is present from where the growing embryo is obtaining the nourishment. In case of dicot seed, two cotyledons are there. Cotyledon means when you are breaking the dicot seed, it will be just broken into two equal halves. Those halves are actually cotyledons. So those two cotyledons are providing the nourishment to the embryo of dicot seed. After cotyledon, there is a presence of embryonal axis. Embryonal axis will be an axis which is present at the middle or at the center. So actually that is, you can consider that is the axis of the embryo, and embryo head portion and embryo tail portion, it will be actually forming along the axis. And then the perisperm. Perisperm is also another portion which is present inside the seed, and this perisperm is the persistent nucellus. If you have seen the structure of the ovule properly, you have seen that surrounding the ovule there are 2 to 3 layers of the cell. Those are commonly known as nucellus. So when the ovule is getting converted into the seed, the nucellus layers or nucellus cell layers remain little bit portion, it will be remaining within the seed portion or within the seed. So for that reason, that specific nucellus portion is giving birth of the perisperm. Next, we have to discuss about whatever the seed types. We know that according to the plant, according to the monocot plant, the seeds will be monocot seeds, and according to the dicot plant, the seeds will be considered as dicot seeds. Always keep it in your mind, in case of dicot seeds, 2 cotyledons are present, that's why their endosperm or albumin protein is totally absent, or if it is present also, that is very minute. So that's why the seed name has been given X-albuminous seed. Clear? But in case of monocot seed, single cotyledon is there, so for that reason endosperm should be there, because that is the added nutritional source or nourishment source for the growing embryo inside the seed. So monocot seed always containing albumin protein or endosperm, that's why they are commonly known as albuminous seed. So from here we can see the types. Now we are again coming to the figure. This is the monocot seed structure, this is the dicot seed structure. Let's see the structure of the monocot seed. Almost you can consider the monocot seed structure is almost triangular shaped, but the corners are rounded. Now always keep it in your mind, the outer layer of the seed, that is here it is written the pericarp. Pericarp means actually it has been given that seed coat, already I have told there is a presence of testa and tegmen. Here the pericarp layer which has been actually written, pericarp is always keep it in your mind the outer layer of the fruit. So here the entire fruit structure I have not drawn, so for that reason pericarp just I have kept as a outer layer, but actually pericarp is not the actual layer of the seed. Seed layers or seed coats are actually testa and tegmen. But pericarp as the outer layer of the fruit present, that's why pericarp here I have written. Again I am repeating. This entire portion, this vacant portion, whatever you can see, this is the stored endosperm, or rather you can say albuminous portion. Next is that here this shield type structure, you can commonly say this is actually called as scutellum. This is actually commonly known as, or it can be called as scutellum. This is the shield like structure found in monocot seed, and that is actually always protecting the embryo. This is the embryonic portion, and this embryonic portion is present inside, and that is protected by this scutellum, shield like structure always. And keep it in your mind, this specific layer which is actually bar like I have just shown, this layer is commonly known as albuminous layer. Albuminous layer. This is actually the albuminous layer. So this layer is commonly made up of albumin protein. Now I am just entering within the embryonic structure. First of all, in case of embryo structure, you can see the apical portion which is pointed, that is commonly known as coleoptile. Already I have shown in this embryo structure, coleoptile should be there, that is the covering of the growing plumule. Next, just below the coleoptile there is a presence of plumule, that means from where the shoot will be originating in future. Next, if you come downward towards the tail portion of the embryo, there you can see the radicle, that means from where the root will be arising in future, and presence of polyorhiza, that is that covering of the radicle. So if you consider the monocot embryo and monocot seed, you can understand this embryo structure is only this one, whatever I have drawn here. So according to that, those structures, that is coleoptile, then your coleorhiza, radical, plumule, those all structures are present. And scutellum, which has been shown here like this projection, scutellum here it is entirely present throughout this lower portion of the seed or lower portion of the monocot seed, and it has been created a shield like structure for the protection of the embryo. Okay, and epiblast layer, which has been shown here, that is actually not shown here, and it is not found distinctly also inside the seed. Okay, so I think the structure of the seed containing the albuminous layer and inside endosperm and all of those layers, I think it is very much clear to everyone. Next we are moving for the dicot seed. In case of dicot seed, already we can see there are two portions, that's why those are commonly known as cotyledons. Here you can see only one cotyledon is present in case of monocot seed, but the cotyledon is not so much distinct. Okay, that cotyledon is, why it is not distinct? Because that cotyledon is mostly making the scutellum. Again I am repeating this point, that cotyledon which is found very distinctly in case of dicot seed, that cotyledon you can't see properly in case of monocot seed, because of that cotyledon has actually made that scutellum like shield or scutellum like covering for the embryo. So for that reason I have not told what is scutellum properly, I have just told it is a shield like structure protecting embryo. But if anybody will ask you that what is the source of scutellum, you will say the single cotyledon which is present in case of monocot seed, that cotyledon is actually making the scutellum structure. So here also scutellum structure is a single cotyledon, that's why you can see it is a single in number. Okay, now I am moving for the dicot seed structure again. So two cotyledons are present, and those two cotyledons is covered by the seed coat always. You can see in the middle there is a presence of embryonal axis, this is the embryo axis. From the upper portion there is a projected end, and from the lower portion also there is another projected end. From the upper portion, whatever the projected end, you can see there the presence of plumule. Okay, but this plumule will not be covered by coleoptile, because always keep it in your mind, in case of dicot embryo, no coleoptile present covering the plumule. As well as if you go towards the lower portion or tail portion of the embryonal axis, you can see the radical is present, but it is again not covered by the coleorhiza in case of dicot seed. Okay, root cap is always present, or keep it in your mind, root cap will be always present. So this is the overall structure of the dicot seed, containing two cotyledons, one embryonal axis, plumule, radical, and hypocot. Another more one important thing is that keep it in your mind, if this is the radical portion, clear, this portion is commonly known as, these two are cotyledons, so this portion is commonly known as hypocotyle portion, and this portion is commonly known as epicotyle, because this portion is present above the cotyledon, that's why it is epicotyle. Here it was there in the embryo structure, and here also hypocotyle, that is the portion which is present below the cotyledons, that's why the hypocotyle portion has been shown here. So this is the total seed-like structures shown. When you will be studying very carefully whatever the difference in between the monocot seed and dicot seed, according to what is the difference between the dicot and monocot embryo, very carefully you will study these points, because these points are very important, and most of the time we are just mingling those things, we are just mixing those things. So for that reason we have to keep it in our mind properly. Okay, in case of, again I am repeating, in case of dicot embryo or the dicot seed 2 cotyledon, in case of monocot embryo or monocot seed 1 cotyledon, and that 1 cotyledon is making the scutellum structure. In case of dicot embryo, you can get epicotyle hypocotyle structure, or in case of dicot seed also you can get epicotyle hypocotyle portion, but in case of monocot seed or monocot embryo, not those specific epicotyle and hypocotyle portions are totally absent. Next, in case of monocot embryo, epiblast structure is there. In case of dicot embryo or dicot seed, epiblast structure is not present. Another more important thing is that in case of monocot embryo or monocot seed, you will be seeing coleoptile and coleorhiza will be present for covering the plumule and radical respectively, but in case of dicot seed or dicot embryo, those coleoptile or coleorhiza portions will be totally absent. So these are the differences present in between dicot embryo and monocot embryo, or rather dicot seed and monocot seed. Okay, I think this portion is entirely very much clear to each and everyone. I am just moving for the next part, and the next part is the fruit. All we know that the ovary portion of the flower is generally or commonly making the fruit like structure. Now if the ovary entirely forming the fruit, then the fruit type is known as true fruit, like that in mango. But in case of some specific fruit, the ovary is not making the fruit-like structure. Rather, the thalamus portion of the flower is actually making the fruit-like structure. So that is the that is that type of the fruit is commonly known as false fruit, because the thalamus portion of the flower is making the fruit structure, rather the ovary portion. And the last point is that parthenocarpic fruit. What is that? Seedless fruit formation. If the fruit is forming without the seed, if there is no seed, as an example grapes, banana, so those kind of fruits are commonly known as parthenocarpic fruit. For making the parthenocarpic fruit, auxin hormone, I think you have listened this name previously also. So this hormone is taking the main charge for making the parthenocarpic fruit, seedless fruit. Okay, coming for the next topic, that is apomixis or parthenogenesis. Apomixis or parthenogenesis is the procedure where any specific new organism is taking birth or producing without any fertilization. Male gamete and female gamete, sperm and ovum, or ovule and male gamete, or you can rather say egg and male gamete in case of plant. They are not fertilizing with each other, but after that also next generation offspring, next generation plants are coming. So that specific mechanism or that specific method of producing next generation offspring is commonly known as apomixis or parthenogenesis. Keep it in your mind, in our agricultural science or in our agricultural aspect, this apomixis or formation of apomictic seed is very much useful, because the question is coming, why apomictic seed is more important or more useful for our agriculture. The reason behind it is for producing normal seeds we have to wait for the double fertilization. We have to perform the pollination, then the pollen pistil interaction will happen, then double fertilization will happen, then zygote will come. From the zygote, entire embryo will be forming within the seed, and then the sapling. But in apomixis, without any fertilization, from directly the ovary and ovule, the fruit and seed-like structures are coming. Seed-like structures, but not the proper seed. So that's why this apomixis is the method which is commonly used in agricultural aspects for producing multiple seeds or huge quantity of the seeds in very less time without fertilization. So this is apomixis or parthenogenesis. Next, what is polyembryony? Polyembryony is the mechanism where you can see, or polyembryony is the phenomenon rather you can say, where multiple embryo you can see inside the seed. Think carefully, why multiple embryo has come? Because multiple pollination, multiple fertilizations have occurred. Okay, if suppose we all know that the normal first male gamete is fertilizing with the egg to form the zygote, and that zygote is actually forming the embryo. But after that also, suppose polar nuclei and second male gamete is fertilizing with each other and making another embryo. If the male gamete is fertilizing the nucellus cell layer which is present surrounding the ovule, on that time also if new embryo will be coming, on that time the option is, or on that time actually multiple embryo is forming. So multiple embryo can come how? Single male gamete or first male gamete when it is fertilizing with the egg forming zygote, that is a normal event, normal phenomenon where single embryo is forming. But if the male gametes will be fertilizing with nucellus cell layer, or if the male gamete will be fertilizing with the polar nuclei cell, instead of forming endosperm, if the embryo will be forming, then multiple embryo will be coming inside single seed, and automatically that event will be called as, or that specific phenomenon is called as polyembryony. Here polyembryony has also very useful role in our agricultural science or agricultural aspect. Why? Because from a single seed, if you get multiple embryo at a time, automatically you will be cultivating multiple plants, or you will be getting multiple plants at a time from a single seed. So polyembryony aspect or polyembryony event is always, it is a boon for us. Okay, because we are getting multiple plants at a time. So polyembryony is also very much important. And polyembryony, how it is happening, how the multiple embryos have come, that also I have told just now. So I think these are the points, that is the embryo structure in case of monocot and dicot. Always keep it in your mind, whatever the differences, keep it in your mind. If it is possible, you make a difference like a column format, that in case of dicot embryo, epicotyle, hypocotyle present, here it is absent. Here the scutellum is present, here scutellum is absent, because here the cotyledon is making the scutellum, here cotyledons are present normally in normal structure. They are not making any projection or shield like structure like scutellum. Next, here presence of polyoctile and polyorhiza for covering the plumule and radicle respectively. Here polyoctile, polyorhiza will not be present. This is the main difference in between these two. And in between this monocot seed and dicot seed, what is the difference? The main difference is, in case of this monocot seed, that's monocot seed, the scutellum like structure will be present, here the scutellum will be absent. Here epicotyle, hypocotyle will be present, here epicotyle, hypocotyle will be absent. Here in case of embryo, that just covering the plumule, that coleoptile is present, and for covering the radical coleorhiza is present. Here coleoptile coleorhiza is totally absent. Here embryonal axis is very much distinct. Here embryonal axis is not so much distinct. So these points you can just write down to differentiate dicot and monocot seed. In case of dicot seed, no albuminous layer is present. That's why they are known as X-albuminous seed. But here a albuminous layer is present. That's why they are known as albuminous seed. Here the endospermic content is almost very minute or almost absent. Here endosperm content is huge for providing the nourishment to the embryo. So many differences only you can write in between this dicot and monocot seed. After that, fruit, true fruit, false fruit and parthenocarpic fruit already I have described. Apomixis, what is the phenomenon? Apomixis is the phenomenon where normally we can make the next generation offspring or next generation plants without any fertilization. So when without any fertilization we can make the next generation offspring, automatically it will be very much easier and it will be taking less time. So it will be a boon for agricultural purpose or agricultural aspect. Polyembryon is also a boon for us because it is a phenomenon where you can see multiple embryo within a seed. So automatically from a single seed multiple plants will be arising at a time. So polyembryony also is a boon for us. And how the polyembryony has performed or how it is happening, that also I have told. That is, if the first male gamete is fertilizing with the egg, normally it is forming the zygote and that zygote is forming the embryo. But after that also the second male gamete is fertilizing with polar nuclei cell, or the second male gamete is fertilizing with the nucellus and forming multiple embryo, then automatically the polyembryony event is happening or a polyembryony phenomenon can be found within the seed. So this is the overall portion or the last part of the chapter, sexual reproduction in flowering plants, which I have totally covered. So you study this portion very carefully. These diagrams please practice because this can also come in your exam. So these diagrams please practice by in hand so that you can draw and you can describe properly their structures. So I think you have understood properly this entire portion and enjoyed a lot. Thank you everyone.